You will be hearing a presentation from Professor Wen-Chuan Wu. Professor Wu is currently an assistant professor at the Department of Computer Science and Information Engineering, National Iian University, Taiwan. Her research interests include image processing, data compression, interactive multimedia, information security, IoT, and STEM education. Today, she's going to give us a presentation entitled Implementation of Intelligence Traffic Violation Report System. Ladies and gentlemen, let's welcome Professor Wu.
Hello everyone, my name is Wen-Chuan Wu. I am from National Iian University. Today I would like to share my experience on applying IoT technology to the traffic violation report. The title is Implementation of Intelligence Traffic Violation Report System. This system is mainly to improve time-consuming film editing, so that manual reporting of traffic violation is faster. In this way, it can also maintain road safety and reduce traffic accidents. Transportation in Taiwan is quite developed and convenient. To reach other cities, people can take public transportation such as mass rapid transit, MRT, bus, and taxis, or use motorcycles and cars to allow them to move quickly. However, private cars are still generally used in transportation. According to statistics, it is found that the high density of motorcycles in the world is in Taiwan, with almost one per person. On average, there are 2 motorcycles per family. This is the family field Skoda waterfall in Taipei, which once appeared in the National Geographic Travel Photo Contest. The main reason is that it has high mobility and is not easily affected by traffic jams. So motorcycle has become the primary transportation tool for most commuters. The number of private cars in Taiwan has been increased significantly in recent years. There was an increase of 116,000 cars in total, from 1216 to 1218. Nearly 16% of family owns a private car, and nearly 13% has 2 private cars. On average, there are 1.5 private cars per family. During the holidays, Taiwan's highways always turn into free parking lots, just like the 2 pictures. Because of the explosion of automobiles and motorcycles in Taiwan, currently it has resulted in many traffic violations, such as illegal parking, running a red, yellow light, wrong-way driving, lane change without turn signals, speeding, and so on. This may lead to traffic accidents and even increase the casualty rate.
驾驶打方向灯要起步，这时后方机车被逼上内侧快车道，其中一名女骑士疑似和灵车擦撞，失控倒地。虽然后方机车紧急刹车没有撞上去，但这名女骑士却倒地不起。
Based on the statistics from New Taipei City, the incidence and the mortality of traffic accidents in 2019 increased by 32.23% and 33.06% respectively compared with the previous year. In order to maintain road safety and to reduce traffic accidents, police and people both can feel evidence for traffic violation through digital tools such as smartphone and dash cam. In this table, it shows the statistics of traffic violation reported by Taipei City from 2015 to 2019. It can be seen that the number of reports is increasing year by year, and the median health of violation are cars. This table is the reporting statistics of New Taipei City, also from 2015 to 2019. It can be seen that the top 3 reports of violations in the past 5 years are parking violations, speeding, and running red lights. Nowadays, people can use car dash cam to record illegal videos on the road and then submit this to traffic violation reporting website. This figure is a flow chart to report traffic violation. First, it is necessary to log into a reporting website and then fill in the personal information of a reporter, such as name, ID number, email, contact mobile number, and address. And then the system will verify the reporter. Second is to provide the evidence, date, time, and the location of that violation must also be attached to the evidence information. The 2 figures are the website for reporting traffic violations in New Taipei City. The evidence provided must have complete violation facts, such as video clips or multiple consecutive photos. License plate and the ground marking must be clearly identified. This figure shows 4 cases of traffic violation, including illegal parking, running red lights, overtaking prohibited, and the ride without a helmet. Figure D provides a single photo as evidence, but in other cases, it should be to provide more than 3 consecutive photos or video clips. However, the volume of video data in a car dash cam is quite huge. A 128 GB memory can store almost 415 videos in high quality for a total of 22 hours. If the video file of 3 million is added manually, it will take 3 to 5 minutes on average. The time cost of edited video is very high. In order to speed up the video edit work of traffic reporting, we adopt multiple IoT modules so that violation chips can be automatically stored when driving. This figure is a diagram of our hardware system architecture. It is designed to use a single chip microcomputer, Raspberry Pi, and the IoT module such as input module, camera module, and the voice module are connected with Pi, and this device is placed in the car. If the driver finds a violation of car, he can press down the button or give instruction to the Raspberry Pi via a voice module. The Raspberry Pi will start the Connect camera to record video. Here, the length of a video clip is 10 seconds, and the file capacity in MP4 format is about 5 MB. Then our system uses recron technique to mount to the cloud service of Google Drive and upload these video clips to the private cloud space synchronously through the Wi-Fi wireless network of the Raspberry Pi. The reporter can download these video materials after return home and upload to the reporter website together with the reporter personal information. We use a Google AI BIOS kit to simulate the traffic violation reporter system and connect it to the Raspberry Pi 4 Mode B and a camera module. This voice kit contains an arcade-style push button, a voice head accessory board, a microphone board, and a 3-inch speaker. This is the process of device installation. Here is the speaker, and this is the button module. This is the microphone extension. Here is the implementation result for our traffic violation report system, and it displays 4 views of this device, such as top view, front view, left view, and the right view. There is a push button for input on the top. When a camera is in front of the button, as shown as this figure, that AI kit in a box has been already connected to Raspberry Pi, a voice headboard, and a speaker. It only needs to connect to the internet and powered by a portable charger, as shown in the 2 figure, to start Raspberry Pi. These are the existing smart speaker products, including Google Home, Amazon Echo, Apple HomePod, and so on. Here is the operation process or smart speaker. First is to wake up device, like "Hi Google." Second is to convert user speech to text. And the next is the dialogue management. In the end, output the understood text into speech. Here we first demonstrated the voice operation of Google AI Voice Kits.
Okay, Google, what's the time right now?
It's 11:53.
Seems to work. Okay, Google, what is the capital city of Pennsylvania?
Harrisburg is the capital of Pennsylvania.
Okay, Google, who wrote The Hitchhiker's Guide to the Galaxy?
Douglas Adams, Owen Colfer, and Adams Douglas wrote The Hitchhiker's Guide to the Galaxy.
First, we use Snowboy to wake up AI voice device. Snowboy is a high consumable wake-up word detection engine to create your own hardware, like OK Google or Alexa. It has the following property. Highly customable. You can free define your own magical phrase, like open door, turn on the light, or hello dream house. The second property is always listen, but protect your privacy. Another property is lightweight and embedded. It even runs on a Raspberry Pi and consumes less than 10% CPU. This is a part of Python code, which is always listening and detecting the web word Snowboy. User can log in to the Snowboy website to change their own hardware. User can click the button to create hardware and then to record your voice 3 times. Step 2 is STT. That is speech to text. Here we use speech recognition API of Google to recognize speech into text. And in the last step is TTS. That is text to speech. Contrary to STT, it is to convert the understood text into speech and output it. Between STT and TTS, there is a step to understand user natural language. Here we use an NLP tool. That is Dialogflow, provided by Google. This tool is used to understand what a user says. Dialogflow is used to build an engine AI to distinguish empathy and intent in the sentence. When a user says, "How is the weather tomorrow?" or Will it rain in Taipei next week? It means that empty is date or location, and the instant is the weather. So user can log in to the Dialogflow website and create a new engine. And then click it to create a new empathize. For a certain entity ID, user can key in the similar word with the same meaning in here. And then to build an entity. Next is to add the chaining phrase to chain the intent. To chain the intent with what a user may say. In this way, the built agent AI will distinguish entity and intent in the sentence. During the experiment, we actually drive a car around 10th Street in New Taipei City for an hour. This figure shows the path of our driving. Our route goes through downtown street and alleys. And this device is recommended to be placed here, near the steering wheel. Allow the driver to operate quickly. Here we show the comparison result of 3 road sessions. This feature on the left is the static result taken by our system, and the picture on the right is the static result of a dash camera. Both of them show the start date and the time on the picture. The dash cam used in the car is the MIL-C 350, and its resolution is as high as 8020 by 1080p. Here is the result on Basin Road. Compare left picture with the right picture. The license plate captured at the same time is still clear and identifiable. This is the result of Zhongshan Road in Tanshui. The left picture shows that a 10-second clip is able to record the violation by using our system when the 2 consecutive cars parking illegal. And this is the result of Zhongshan Beilu in Danshui. Only when the sunlight is very sufficient, such as the 2 pictures, the license plate captured by our system is too blind to be recognized. This problem will be improved by using high-quality camera module. Here is to show traffic video clips recording using our system, which are stored in the private cloud space of Google Drive. The reporter can download these videos when return home and upload to the report website together with the reporter personal information. In our simulation, a total of 19 video files were stored on the cloud platform, and each video is 10 seconds in length. Here is to show the success rate of voice instruction using our system. In our system, the instruction snowball is used to wake up the device. There are a number of 46 successes. So the success rate is 92%. And we use 3 instructions about 开始录制 in Chinese, start record in English, record in English. By using the 3 instructions to control the Raspberry Pi to rec the video. From this table, it can be seen that when the voice instruction is longer, it is easier to recognize successful. That is, the success rate is higher. In the end, I would like to make some conclusions for today's presentation. In this implementation, IoT technology is used to connect multiple modules, such as button module, camera module, and the voice module, to communicate with each other. When a drive discovers a violation, he can operate the input module or voice module, and then the camera will be active to record a video clip. These videos and the related information such as day, time, and the GPS location will be automatically uploaded to the specific private cloud space, which can reduce the time cost for the reporter to report traffic violations. After the simulations, it was found that the 80 clips can be successfully used on the violation reporting website, and the reporter saves nearly half of processing time to edit the video in the dash cam. This is my presentation. Thank you for your attention. If you have any question about this presentation, please email to this mailbox. Thank you very much.